So we are playing a game. Okay, let's fast forward a little bit. I'm dropping a resources card, I'm changing turns, I'm dropping another resources card, and I'm dropping a new unit. The unit is flat-footed, so that means I cannot attack this turn, but on the next turn I'll be able to attack when I am on the battle phase. Okay, so we need a logic that is going to make us able to move him forward, or say that he's actually attacking. We're going to just initiate it by just moving this card forward. Okay, and then so how should we do this? We need to create some logic that whenever we are clicking something inside this phase, we need to give us some feedback on what we are clicking. And if it's a card that is our own card, of course, and it's inside our area down, then it's going to be able to attack, if it can attack, of course. So how should we do this? Let's check a little bit how our logic works. Of course, you remember that we have our turns, we have our player turn, and inside the player turns we have a few phases. The first, some phases like the reset current player card resources, it's automatically moves to the other stage. And then on the control phase player, we have a player control state. In that player control state, we are running actions that are actually able to work with. Okay, so similarly, we're now going to go onto our battle phase, and we're going to have a battle phase control, which means we can right click in here and create a new state, which we're going to say battle phase control, or controls, whatever. So drag and drop this in here, and right now of course we don't have any actions. We can start creating a few actions, however, and we can say on mouse click what happens when you are well, we can take a look at the logic. It basically does a recast, and it gives you, if it's something you can click on, it's going to run the interface that we have assigned. And if we have, for example, I don't think we have it, either on the card distance we have the iClickable, okay, and it means on click it runs some logic we have over here. Right now I think we only have the my card down logic, which basically does nothing. Okay, so let's create a new logic, however, and instead of calling it, let's find our phase again, phases, battle phase control. Instead of having the on mouse click, we're going to do something similar. So let's open up this on mouse click, and let's find the place we have this. Should be inside asset script actions. So asset scripts actions over here, and let's create a new class. Let's call this battle select cards to attack. Open it up, select card to attack. Let's delete all of this, let's add the namespace, and I believe we have this named as action. Okay, change this from auto behavior to action, and create asset menu. Let's paste this above. We need to add the namespace, and we also need to implement the abstract class. Instead of on mouse click, I'm just going to say select cards to attack. Then on mouse click, I'm going to copy all of this, and I'm going to paste them in here. But instead of looking, let's also add we need the collections.generic for list to work, and recast results, we need the event system. So Instead of doing instead of searching for the iClickable now, I can search for the card instance. So if art dot actually, let's see how we had it before. Clickable. Okay, Control Y. And bring this back. Okay, for each recast result, let's say card instance art.gameObject.getComponent in parent card instance. Okay, so we have a card. If this card now is ours, so we need to check if it's our own card or if it's the current player's card. And just for a refresher, for me mostly, let's go on to the game. Let's see the settings. We have our game manager over here. Let's see, we want to check if it's for the current player, if it's a card that the current player has inside his cards down. Okay, so we need to check if it's belong over here. How do we do this? If settings game manager dot current player dot cards down contains instance, and if it does, then that means we are free to continue, but let's say return over here. If it doesn't, we don't want to do anything, or you might want to do, you know, some highlight or something like that. We'll see that on that later. And if it does, then we need to check if this card can actually now attack. So from the card instance, let's do a quick definition. We can find the actual card from the card.viz card, which means we can go over here and create some additional logic per card, and we can say public bool can attack, or I guess we could do this right from the card type on set, and we can also say public virtual void virtual bool can attack, and return false. Then on our card types, although I think we don't have that much of yeah, we have different, we haven't separated the card types by that. Okay, let me think. So okay, let's say that on card distance we're going to have a reference over here, and if you can, well, a method public bool can attack. Okay, then for example we can say bool result equals false or equals true, I guess, since most of them should be able to attack. Result equals or return result. However, if is flat-footed, result is false. Now we need to be checking with the actual card types we have. So let's go on the card type and let's add public bool can attack. Then for public virtual, actually we don't necessarily need to be virtual, let's just go this bool can type allows for attack. And we need to be passing the card distance, because later we're also going to add some additional things. For example, you'll see card distance. Let's call this instance, and if can attack, return true, else return false. Okay, so let's set it like this, and we can add some additional logic over here. For example, public type logic, logic, and say, let's give an example just so that you know what I have in mind. Okay, flying type can attack if even if flat-footed. So basically, if this card has flying, doesn't falls flat-footed. Of course, all these are examples. Let's give some sample code. We'll say logic bool result logic dot something like that, execute, pass the instance. The instance should be checking on that. Inside that execute, we can check if instance dot is flat-footed, change it to instance dot is flat-footed equals false, and return true, something like that. Okay, so okay, and of course you can add additional logic. You can say that if you attacked before, then you can attack right now, and all those things. This is just some example. Anyway, so let's go select all of this, and let's go back onto select cards to attack. And here, okay, if it's not your card, of course you can't attack. Then we can say instance dot if instance can attack, and then you can attack. Let's bring also the type checks inside the instance. Result, let's say is flat-footed, set that false, and if for this, actually let's do a for loop. This dot card type dot count. No. Oh, there's only one card type. Oh, that kind of makes it easier then. Okay, so cut this. Actually, I think we don't want only one card type, however. Well, okay, let's do it like this then. If can attack, and not can attack, we want type allows for attack. Pass this for the instance, then result equals true. Okay, we should probably also check for this, to be honest. Yeah, it's not necessarily doing a lot of things right now. We might move the flat-foot check inside the allows for attack. We'll see. Okay, but let's leave it over here. So let's say that select cards to attack if you can attack. Now we need to set it up so that you're actually indicating that these cards can attack, which means we can go now onto the player holder the similar way we have the cards down. We can add a new list for the card instances for the cards to attack, or attacking cards, I guess. Then, instead of from cards down, we're going to be looking at attacking cards. So, back to the action. If the instance can attack, then settings, game manager, current player, attacking cards. Since we are going to be using the current player a lot, let's say player holder, settings, game manager, current player, player, attacking cards dot add the instance. Okay. We should also bring this card forward though, and we can do this by saying instance dot let's see, can attack. Okay, the card visualization. Okay, highlight is flat-footed. Okay, card holders, set parent for card. This is just to help us. Okay, resources, hand grid, resources grid, hand grid. You know what? Let's just say, let's go on to this. Let's eyeball it for now. It's not necessarily something, you know. Doesn't have to be something elegant at this time. And pretty much need to bring this. It doesn't let us bring it upwards because we are inside the grid layout. Let's say we want to move this on the horizon line or whatever that is. And let's maybe rotate. Okay, I guess something like that. So it should be placed at this position. So we are going to add a new holder for this. Let's say, let's duplicate this, and let's say battle line. For battle line, actually, let's just add. Let's make this something universal. I'm going to delete that, and I'm also going to delete the assigned transform. I'm going to change this, and I'm going to change this to battle line. Battle line. Let's call this battle line. Okay, we have the assigned transform, and we now need to move the cards on the battle line, and the similar way we are doing it with this kind of variables. Let's find, I think it was the card holder. Hold on for a second. Okay, so on to card holders. Let's add one more transfer variable, and this will be the card battle line. Okay. Oops. And over here we can say public void load, not load, set card on battle line. Card distance, card. Okay, set parent for card. Then we have the same way we're doing this, but let's go over here and say set parent for card. Okay, this will set it at 000, so we can say set parent for card.vis game object, and make this the battle line.value.transform. Okay, but card.vis, actually let's just do this, vector3 position equals card.vis.gameObject.transform.position. This will parent it, so it's going to be outside of the grid. So we can say card.vis gameObject.transform.position. It will be position plus vector3.1. Yeah, that's going to be horrible, so forget that. Let's just assign the x, because the battle line is going to set it at 0, 0, 0. So let's just say position dot z card.vis dot gameObject to transfer dot position dot z, position dot y card.vis gameObject transform position dot y, and then the x is going to be the original it had before. So all it's left to do is say card.vis gameObject transfer position equals position. Okay, set card on battle line then. Select cards to attack. Now we need a card holder. I think we can find this. Card, set parent for card. How do we find the card holder though? Let's do find our references. Card holder. We find it directly from the player holder. Awesome. So back to this. P card holder or holder, current holder dot set card on battle line instance. Awesome. Let's go and build this now. We have our cards. Let's find the containers. Let's check all of this. Player card holder, battle line. The battle line is only going to be one. Actually, let's do two battle lines. Let's say battle line, player battle line, and enemy battle line. Okay. On the containers again, enemy battle line, player battle line. Okay, so drop this down here, player battle line. Let's zoom in a bit, and I'm going to move this around here on the end of this, and I'm going to duplicate the enemy cards down, and I'm going to say enemy battle line, and I'm going to bring this over here. So when you are blocking, or when you are when he's going to try to block, the cards won't really sit on the same position. So maybe let's move this a little bit higher. Okay, so assign, we don't want the grid anymore. Assign cards. Transfer variable for this is going to be the enemy battle line, and the player battle line is going to be that. Okay, then let's go find our actions. Data, player actions, create actions, select cards to attack, which means this is going to go now onto the battle phase controls. Instead of on mouse click, we're going to have select cards to attack. Awesome. You see that we write code a lot, but it's just a lot much faster afterwards. Okay, so we don't have a battle phase because we are flat-footed, but over here, let's see, nothing happens. Okay, so why nothing happens? Battle phase, We have battle phase control. Let's open up our battle phase. Nothing happens because we don't really do anything with the battle phase control. Oops. On start phase, set state. If not, force exit. Battle phase control. Game. Current state, player control state. So this should have been. Yeah, that's actually wrong. So if we go instead of the player control state, switch to battle phase controls, you will see that it now plays correctly. You are actually on the battle line. But yeah, this should I should probably check why that is. So hold on. So yeah, apparently it was working fine. Maybe I forgot to hit enter, I don't remember. Okay, so let's drop 2 of these. We also have another bug, as you can see. For some reason it doesn't take it as we have enough resources to drop the card, even though we do have them. Yeah, probably need to check that, and you can see that it taps only 2 of them, so maybe we have a bug somewhere. Okay, enemy control, player control, we don't really need anything for the player control. And turn, battle phase, and voila, it's ready to attack. Okay, so when we are actually clicking and turn on the battle phase, it's going to be going on to a different state. Instead of just battle phase, will be the battle resolve state, which is going to be a universal state. So the other player is going to check if he can actually block, and if he can't block, then he takes damage, and that's it. So let's finish with this, however, now with this part, and on the next one we're going to bring all the things we talked about. So as always, you know what to do: like, subscribe, and if you like to see more games like this, more tutorials, all this stuff, then consider supporting me on Patreon so we can keep making all of these beautiful things. I'll see you next time.